Hello, geometry, and here we go with unit 5. It's the last full unit that we're going to do in first semester. So let's go ahead and jump in. Ratios and proportions. So a lot of this is actually review. There's a little bit of new stuff, but you've done a lot of this stuff before. So learning targets: understand the difference between a ratio and a proportion, use properties of proportions to rearrange proportions, and set up and solve proportions. So some vocabulary. Another name for a ratio is a fraction. And then a proportion is a statement of two ratios that are equal. All right, so right away, we got this thing right here. So each piece, the A over B and the C over D, those two things are ratios. Most of you probably know this, but I'm just making sure here. And then the together, everything together here is a proportion. Abbreviate proportion. Okay. I'm gonna go ahead and erase all that because it's in the way. So now let's talk about the properties. There's 4 properties that we're going to talk about. So if you have A over B equals C over D, then you can say that A times D equals B times C. And that's just cross multiplication, which most of you have been doing for a long time. All right. Okay. The next property says that if A over B equals C over D, well, then B over A equals D over C. And those are just reciprocals. So if you take the reciprocal of both, okay, they're still equal. That should make sense. If you've got 1/2 equal to 3/6, and that's the original statement, well, if I flip this one, 2 over 1, it's going to stay equal if I flip the other one, 6 over 3. Okay, they're both reduced down to 2. All right, I'm going to go ahead and clear that. Scroll down to 3 and 4. So again, if A over B is congruent to C over D, then A over C is equal to B over D. Now that one you probably haven't seen. So what that one is, the ratio of the numerators is equal to the ratio of the denominators as long as you go in the same order. So I'll use that 1/2 and 3/6 again. What this is saying is the ratio of these and the ratio of these are equal. So I'm going to do 1 over 3 equals 2 over 6. Doesn't matter what proportion you look at, you can do that. But you have to go in the same order. So if I start with 1, I have to go to 3. If I start with 2, I've got, and then I got to go 2 to 6. Okay. The last one is definitely weird. It's A plus B over B is equal to C plus D over D. And people are like, what is that? Let me try to explain that here in the next little bit of time. Okay. So I'm going to use my property of fractions, which says that A plus B over B, I could rewrite as A over B plus B over B. Common denominator, I'm separating the fraction, right? Well, then what's B over B? Well, that's just 1, right? B over B is just 1. And if I look at C plus D and do the same thing, C plus D over D is equal to C over D plus D over D. Well, D over D is just 1. Right? And so what I'm saying is if I add 1 to both sides, the ratio is still, or the proportion is still equal. Okay. These properties are going to be used throughout the unit. Okay, so you're expected to recognize those and understand where they come from after this lesson. So we're going to start using those properties with numbers 1, 2, and 3 here. So if a over 4 equals 12 over b, then a times b equals, hopefully you see that it's 48. Where did I get 48? 4 times 12, right? I'm gonna go ahead and simplify it if I can. In this case, I could. All right, b over 12, so that's the reciprocal of the second ratio. So I'm gonna take the reciprocal of the first ratio. So it's just gonna be 4 over a. Third one, a over 12, that's the numerators of the original. And I started with a, so I have to start with 4 over b. Okay, that's just using the properties in this, those examples there. Backside. Now we're actually going to start solving proportions. This is algebra. Okay, so we're going to use that cross multiply idea quite a bit here. So what I'm doing is 4 times y plus 3. Now I got to do the whole 4 times the whole thing. To do that, I need to use parentheses. And then 8 times y, you can use parentheses, but you don't need to since it's a single y. Okay, distribute, I get 4y plus 12 equals 8y. Subtract my 4y. And you get 12 equals 4y. Divide by 4, you get y equals 3. Okay. Now, the next two are going to give people fits. Second one's not too bad. All right, but there is something that happens here. What's x times 2x? A lot of people are going to say, oh, it's 2x. No, not quite. X times x is x squared. And then 2x times x is 2x squared. 3 times 6 is 18. Now, I have an exponent of 2. Okay. That's a little different. Okay, I want to get x squared by itself, so I'm going to divide by 2. So I get x squared equals 9. A lot of you are going to be just fine with this. Take the square root. Yeah, that's no big deal, right? You're going to say x equals 3. And you're going to miss points. Because I'm looking for any number that when I multiply it by itself, it gives me 9. Well, 3 does that. But what else does that? Negative 3. Might not remember back in Algebra 1, but when we take the square root of a positive number, it's plus or minus 3. So 3 and negative 3 are answers here. And you can check it. Take negative 3 and put it back in for x in both places. You're going to get that the two fractions are equal. Okay, so negative and positive 3, you get 2 answers here. And I circled that exponent up here. It's kind of your clue. When you get an exponent of 2, you're probably going to have 2 answers. Okay, so let's jump down to the next one. This one's tough. So you're going to do x minus 2 times x plus 3. Oh, and by the way, when I say it's tough, we are doing this. This will be on a quiz. You'll probably see it on a test. 2 times 7, 14. Now, when you have a binomial times a binomial, you should remember this. This is FOIL. Some of you might have learned the box method. Okay, some of you might have learned distribute twice, depending on who your Algebra 1 teacher was. I taught FOIL and box. So FOIL is x times x, and then x times 3, and then negative 2 times x, and then negative 2 times 3. So I'll do that slower here. X times x is x squared. X times 3 is 3x. Negative 2 times x, and yes, that is a negative 2. And then negative 2 times 3 is negative 6. And then don't forget that it's equal to 14. I'm going to combine my like terms here. I get x to the second plus 1x minus 6 equals 14. And most people are okay with that part. But then they get here and they're like, okay, what's next? And they want to add 6 to both sides. But it's a little bit weird here. With a quadratic, which is what we have here, quadratic with an exponent of 2, I want this thing to be equal to 0. So I'm going to move the 14 over. Okay, so I'm going to get x squared plus x. Negative 6 minus 14 is actually negative 20 equals 0. Now I want to factor this. I'm throwing pretty much all of the quadratic unit at you in one problem here. All right, I want to factor this. So I want to find two numbers that multiply to negative 20 and add to 1. Okay, what two numbers do that? Multiply to negative 20 and add to 1. It'd be 5 and negative 4. And you're probably thinking, oh, we're finally done. No, actually, we're not. We still need to find the x values that make this equal to 0. So what I have to do is I'm going to set both of those things equal to 0. So x plus 5 equals 0, and x minus 4 equals 0. Subtract 5, you get x equals negative 5. Add 4, you get x equals 4. And like I said, you get two answers here. So my answers are x equals negative 5 and x equals 4. All right, both of those numbers, if I take them and plug them in for x, they will give me an accurate statement. And I'm going to do that right now on this one. So negative 5, put it in for x, plus 3 divided by 2, 7 over negative 5 minus 2. And let's simplify both fractions. Negative 5 plus 3 is negative 2 over 2. And then negative 5 minus 2 is negative 7. And then 7 on top. And both of those are going to reduce to negative 1. So they reduce to the same thing. That's what we want. Now I'm going to take 4 and plug it in. Show you that you can also get this a true statement when x is 4. So 4 plus 3 divided by 2. 7 over 4 minus 2. 4 plus 2 or 4 plus 3 is 7 over 2. And look what happens on the right hand side. 7, 4 minus 2 is 2. 7 over 2 equals 7 over 2. Both numbers made true statements, so they're both solutions. Okay. You are going to have to do that. So if you want to watch that again, might be a good idea. Okay. Last one, set up and solve a proportion. So the setup is the part that's a little bit different here. All right. On a certain map, the scale is 3 inches to 70 miles. That information, very important. That gives me a ratio. I'm going to write a ratio real quick. 3 inches. I like to label them too, because you'll see why in a second. 3 inches means 70 miles. And so I got that. That's my ratio. Then it's going to give you something else. So you're going to have a proportion where you're going to have one known and one unknown. Okay. It's not even that hard, but you want to take the last known piece, which is 110 miles, and put it in the right spot. Well, if you labeled your original ratio, you should see that the miles was on the bottom. I gave you miles. So 110 goes on the bottom. How far is it on the map? Well, the map is in inches. That's what we don't know. That's where my x goes. So there's my proportion. I'm just going to copy it down over here. 3 over 70 equals x over 110. And then you solve it. You get 70x equals 330. Divide by 70. It's not going to give you a nice number. You get like 4.714. I didn't say what to round it to. Oh, wait, yeah, I did. To the nearest 10th. So 4.7. And make sure you understand the label here. X is in inches. So 4.7 inches on the map. Okay. And that's ratios and proportions. We'll take this to some figures in the next lesson. But make sure you understand the algebra in this one.